Good evening, students. I will start with the class. In the previous class, we had done the topic energy. So we had seen two main ones, that is kinetic energy and the potential energy. Now here, this is today's topic is something is power. What was work done? What was the formula for work? Work is nothing but always force into displacement. Power is nothing but how much of work you are doing in a given particular time. Okay, so as per the definition, power is defined as time rate at which work is done or energy is transferred. Energy and work is same, we have seen that already. It is just the capacity to do work. Units, formula, everything is same for energy also. So what is power? Power is defined as the time rate at which work is done or energy is transferred. So basically, power is nothing but work done upon how much time has been taken to do this work. So P is nothing but W upon T. So what will be the units? Units of power. Okay, units of power will be, you know that work is what? Joules. Joules upon time. Time is nothing but second. Joules upon second. Or also that is watts of watts. 100 watts or 100 watts. Some pronounce it as watts, some pronounce it as watts. Normally 100 watts will be, or this 1000 watts is always called as 1 kilowatt. And there's one number that is 746 watts is called as 1 horsepower. 746 watts if you have, you can call it as 1 horsepower. 1 horsepower is basically 746 watts. It's a scalar quantity. There's no need of direction for this. Power is a scalar quantity and its dimensions are, if you know the work dimension, it's just that time will be one extra. If you take it on top, it will become minus. So work dimensions are what? M L2 T minus 2. Here only one time is extra. So this will become minus 3. The dimensions of power are M1 L2 T minus. And if you want to know what is power efficiency, means how much efficient any machine is working, you have to always check how much output it is giving compared to how much input it got. Output power always upon input power. Normal in mathematical form, power formula I just now told you is nothing but work done upon time. Now suppose if you want to use it as a dot product or in terms of vectors, power in terms of dot product. Power can be written as change in work upon change in time. Okay, always final work or whatever done or minus initial upon the time difference. So power is nothing but work done in particular time. It's nothing but work done upon time. So if you're using D, you have to use D for the time also. But you know that work done is nothing but force into displacement. Okay, but in terms of dot product, we always use like this, and then we used to write what? Fs cos theta. This was the formula which we studied for work. Two ways we can write work. One is F dot S, force into displacement in terms of dot product. If you are removing the dot product, it is cos theta. If I am using dW, this will be force will never get dF, only small displacement, small work done, small displacement. So this will be dF. Work done is nothing but force into displacement. I'll just put the value of this work over here. The power will be what? F bar dot ds upon dt. Put the value of dW in the power equation. This dW is F dot ds, put it here. So it will become F bar dot ds upon dt. Now just separate this. Multiplication means you can always separate. It's like 2 into 7 upon 4 can be also written as 2 into 7 by 4. You know that change in displacement, change in distance upon time. Distance upon time is nothing but velocity. But we know that ds upon dt is nothing but or change in displacement upon change in time. You don't need to write this. This is only for understanding. It's basically nothing but velocity. You know this. So as per that, what will be this logic? I'll write it again here. Change in distance upon time will give you v, velocity. So put it here. So power is also equals to force into velocity. Can also be written as dot product of force and velocity. This is another formula for power. You can either write it as work done upon time, W upon T, or F into V. So two formulas, keep on somewhere on the top of the page and write and keep. Power can be solved as like this or in two ways. If you know the force and velocity, you have to use that formula. If you know work done upon time, you can use that. Now the major part, the last topic, that is the major topic actually, collision. Whenever we say someone met with an accident, it's nothing but why does an accident happen? It's nothing but an collision between two objects, whether it may be between two vehicles or whether it may be vehicle and some other object. Okay, so what happens is basic collision, nothing but a collision occurs between two bodies if they collide against each other. Collide means dash against each other. Or if path of one body is affected by the force of another body. Basically what it means is if one is already there on its place, but second body comes and puts some force on the first body which is already there, what happens, this path, if he was going straight, something comes and collides, he may change its direction. So the path of one body may get changed by the force of another body. So that the collision is something what physically dashing against each other. So if there was one moving this side, okay, suppose if this one comes and hits, okay, this may be at rest. If this one comes, it may either move in this direction, okay, M1 and M2. It will collide and then it may start moving. Or one more option, suppose if they were coming like this, so they will dash each other, okay, and then what can happen, there are so many ways. One way is for this, based on the speed, okay, this one speed and the other one speed, they may dash and then they may start moving in the opposite direction. If you have played this with marbles and all, suppose if you, or even carom, if you have played, you must have seen sometimes both may go in the opposite direction, sometimes one this will go in one direction only. If you have not played carom, you may not understand. But basically normally whatever it is, two bodies you can imagine, they will collide against each other, or one this truck and a car, they may collide. So there are various ways they may get separated like this in both the directions. Or if the truck is very this heavy, he may push in this direction. Okay, or one option is, this is one case, this is second case, or it may start moving this side. Various ways there can be movements. Will be the third case. So whenever two things collide, the different cases can happen. They may move in the opposite direction from where they were initially moving. This was what before collision. These are the cases which can happen after collision. So they can move in the opposite direction, or both may move in the same direction. The other one may come in the opposite direction, or one may stop only. This one might stop, the other one might keep moving. Various things can happen during a collision. Basically, there are two types of collisions. One is called as a elastic collision. The other one is called as inelastic collision. Now, based on what has been decided, elastic and this inelastic is based on the momentum and some kind of kinetic energy. Now, what happens is, initially before collision, no, suppose if there was one object of mass m and another object of mass m2 over there, so that might have some velocity u1 and some velocity u2. This would be before collision, suppose. Now, after the some collision will take place. Okay, then after collision, what will happen? Suppose if they move in the opposite or whichever direction it may move, any of the 3 or 4 cases which I told. Right now, I'll take this one. They must be moving somewhere else. So that same velocity will not remain after collision also. Its velocity will change. So that would be v1. This one would be v2, suppose, after collision speed. Okay. So whenever I say something like total momentum remains the same, whenever I say the total momentum might remain same, means what? Initial momentum is always equals to the final momentum. Suppose initial momentum, don't write this, I will give you separately what it means. So what is normally the initial momentum? This, what is that? Momentum formula is what? Mass into velocity. Momentum formula is mass, that is p letter, into velocity. So what is your initial momentum? Initial momentum would be here, I'll write m1 u1 total, okay, plus m2 u2 is called as an initial moment. After this is called as the final momentum, m1 v1 plus m2 v2 is called final moment. Okay. Now write this, draw this diagram and write this is the initial momentum, this is the final momentum. And based on this, what happens before and after collision, what happens to the momentum, you'll have to give two names, that is elastic collision and inelastic collision. Okay, so what happens is basically, okay, here only as a side somewhere you write and keep like that. Same way here, initial, okay, or kinetic energy before collision. Kinetic energy before collision would be half mv square. So half m1 u1 square plus half m2 u2 square. Same way, kinetic energy after collision will be kinetic or energy of this one plus kinetic energy of this one. Half m1 v1 square plus half m2 v2 square. This is kinetic energy after collision. Kinetic energy formula everybody knows, that is half mv square. So for initial, before collision velocity, we have to use the letter u1, and after collision letter we have to use v1 and v2. So u is for initial, v is for final. So that's the only difference. Now based on these two things, we'll define this one. The first one is elastic collision. A collision in which kinetic energy is conserved is called elastic collision. Conserved means what? Remains same. It is not lost. Before collision, kinetic energy total will always be equals to total kinetic energy after the collision. Conserved means it remains the same. It is not lost in the environment. This momentum, there are 2 points here. Linear momentum is conserved. Means what? Initial momentum is always equals to your final momentum. So whatever is your initial momentum will always be same as this. So as per that, m1 u1 plus m2 u2 equals to m1 v1 sum of the initial momentums is always equals to sum of the final momentum, is before collision and after collision. This part is before collision and this part is after collision. So this is the first point for elastic collision. Second important point is just of kinetic energy is conserved. Means what? Kinetic energy before collision equals to kinetic energy after collision. Half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2. kinetic energies before collision is equals to kinetic energy after collision. If these two conditions are satisfied, that means it is called as a elastic collision. Third, also you can say energy or mechanical energy, you can say is conserved. That is, does not get converted. Does not get converted into any form. Means there are various forms of energy, okay? So whatever is there, that energy tries to escape in various forms. Now imagine when an accident is happening, okay? The accident will never happen like in a silent mode. Some sound will be there. So what happens when two and these vehicles collide? You will get some. You can hear some sound. So what happened? Their energies, whenever they collided with each other, so there might be some spark also. So energies try to escape in various forms. So whenever you hear that sound, no, little bit of the energy of the vehicle, no, which it was moving with, it got converted into sound when it dashed with the other car. So some mechanical energy of the car gets converted into sound and it is lost in the environment. Okay. Same way, it might produce some spark. So some energy might go in form of sparks. Some may go in terms of friction. So various ways the energy may be lost. So that is the second case we will come across. So whenever accidents and all happen. But elastic collision, no, what happens? Whatever is the mechanical, no energy is lost anywhere outside, not in the light form, not in sound form, nothing. It does not get converted into any form. Whatever was there in body one, either it will get transferred to body two or this, or somewhere among them only it remains. It never goes out in the environment. Okay. But in case of inelastic collision, we will come across whenever two body collide, there will be some sound coming out. There might be some light. There might be something or the other, some other form of energy, some frictional energy, something will go out. But in this case, everything remains conserved. Nothing is lost. So mechanical energy is conserved. That is, does not get converted into any other form. So that's why whatever was before collision remains after collision. So example would be this happens only like in a very closed environment. So that example would be collision between subatomic particles. Usually, no, this is more very rare cases. So very difficult, no, to control loss of energy in some form or the other. So this is like a rare case, collision between subatomic particles. So it's in a closed environment. Sometimes there could be heat energy also in the form of heat. Okay, light, heat. The vehicle might become like heated up after the collision. Okay, so it can be lost in that form also. But in this case, subatomic, there is no energy loss. So this is one example of elastic collision. This is like at a microscopic level. And the second type is a inelastic. So obviously it is opposite of elastic. So a collision in which kinetic energy is not conserved. is called inelastic collision. In both the cases, no, linear momentum will always remain same. Current way. Okay, so able to see the board. Inelastic collision, okay, in both the collision, no, momentum remains the same, but kinetic energy is not conserved. So in linear momentum, initial one, okay, initial momentum you can say is equals to final moment, that is after collision, and this is before collision. This point is same for both of this. M1 U1 plus M2 U2 is same as M1 V1 plus M2 V2. This condition is common for both. So no matter what collision it is, momentum always remains the same. That is what M1 V1 and M2 V2. Only kinetic energies, that is when kinetic energies come into picture when it is moving with when the object is in motion. So kinetic energies will not be the same before and after collision. Initial kinetic energy or kinetic energy before collision is not equal to kinetic energy after collision. This is the important point. Put a star. This is what it makes it different from elastic. So kinetic energy before collision is not equal to kinetic energy after collision. So this you can write half mu1 u1 m2 u2 is not equal to half m1 v1 plus half m2 v2.
Excuse me, miss.
Yes. Okay. The third point. First point is same, okay, for both. Second point is different. In that case, it was equal. Here it is not equal. Third point is also different. There, what was happening? Energy was not lost. Here, energy is not conserved. That is, energy gets converted. Either in light energy form, sound, heat energy, etc. Example, collision of two vehicles. So there will be sound which will be coming. Okay, there might be some heat produced. There could be some flash of lights produced. So various forms, energy may be lost. Energy is not conserved here, so that is energy gets converted either in the light, sound, energy form. You can say mechanical energy. Huh? There we use the word mechanical now. We use mechanical energy gets converted either in light, sound, heat, energy form. So this is the difference between elastic and inelastic collision. Inelastic, remember, in both cases momentum is same. Then about kinetic energy, in first case it is equal. Okay, here it is not equal. The energy is not lost. Here energy is lost. Now we will derive elastic collision in one dimension. Elastic collision in one dimension. We will draw this diagram. Suppose there were two objects which are moving. One is m1, which is moving with velocity u1, m2 moving with velocity u2. So first write this is before collision. Then m1 again m2. This is you write it during the collision. And then the third one after collision will be. So they can go again back in the same direction also, no problem. M1, M2. So this is V1, this is V2. This would be after collision. After collision, definitely the speed will be different. To write the description part, consider two masses. Consider two masses M1 and M2. Moving along straight line with initial velocity u1 and u2. u1 and u2. After the collision, after head-on collision, head-on collision means they dash each other. They continue to move. Suppose like one vehicle was moving, the second vehicle comes and hits the first one, but then they keep continuing moving. They continue to move along a straight line, in the same direction. It becomes reverse side to right. One second. Continue to move along a straight line in same direction. With velocities v1 and v2 respectively, right? With velocities v1 and v2 respectively. Okay. Now we know what is the law of conservation of momentum. That initial momentum is always equal to final, no matter which collision we are following, whether elastic, inelastic. We saw that momentum anyways remains the same. So from law of conservation of momentum, we know that initial momentum final moment. We know that initial momentum is equal to final momentum. So we know that m1 u1 plus m2 u2. This should be simple for you now. Mass into velocity is total momentum before the collision and is equals to total after collision. How we come to know? Final means v, it will be. Initial means u. That's the only difference. So m1 u1 plus m2 u2 will be equals to m1 v1 plus m2 v2. What we'll do? We'll bring mass 1 on one side, mass 2 on the other side. So this is m1. So this one I'll bring this side. m1 u1. This whole term I'll have to bring. So this I'm bringing side, so it will become minus m1 v1. This I'm keeping here only, so his sign will not change. Now this fellow with m2 I'm bringing this side. m1 u1 minus m1 v1 equals to m2. Okay, so mass is basically whichever have the same mass, I'm bringing those terms one side. So what is common now? m1 you can take out common. So you can take out m2 common. Mark this as equation 2. This as equation 1. Now for elastic, this is common. Okay, we know by default this is anyways momentum always remains same. The second thing is for elastic, we know that kinetic is also same. For kinetic, for elastic collision, we know that initial kinetic energy equals to final kinetic. That is, kinetic energy is conserved. So write half m1 u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. And same like the previous one, what you do, m1 terms you bring one side, m2 terms you take on the other side. So let m1 with mass 1 be on the left hand side and with mass 2 be on the right hand side. So as for that, this term you'll have to take on this side. This I'm keeping here only. This one I'm bringing this side. Now take out m common. Bulb, there is some issue. Please can get another bulb, okay? Current is not coming on, it's getting down. I just put on the cell torch. Okay. Okay, so here half m1 you can take out common. So if you take half m1 common, what will remain inside is this u1, no? So u1 square minus this was what v1 square. So here also take out half m2 common. So this will be v1 square minus u2 square. So this you mark as equation 3 and this you mark as equation 4. Now what we'll do is divide equation 4 by equation 1. Or sorry, equation 2 will divide. Divide equation 4 by equation 2. So as per that logic, this is half or before that one more second, one more thing you can do. Half and half you can cancel and keep. Both the sides, half is same, no? So it will get cancelled. So equation 4 will be m1 divide by equation 2. Same way, right hand side will get divided by right hand side. So what will happen here? M and M will cancel. And this is in the form of a square minus b square. We know that a square minus b square is a minus b into a plus b. So using that formula, a square minus b square. So split this as a plus b into a minus b, or a minus b into a plus b. So this will be, so this and this is same. Here also is split. This is what V1, sorry. V1 minus V2. So this will also cancel. So what remains here? U1 plus V1 equals to V1 plus U2. Now bring U on one side, V on the other side. So this will be U1 minus U2. One second now. Both how it became V1. This I wrote ulta, no? This was 2. This was 1. Just see, huh? Just correct this, huh? This was 2, this was 1. Make everywhere this. This is 1. While taking out common, I must have made something. This is 2. This is sure, huh? 2 and this is 1. 2, 1. Okay, so this is also 2 and 1. 2. This is 1. This will be 2. This is 1. Then this. So what remains is V2 and U1. Just correct it on the right hand side, huh? While writing, I must have written reverse. This is 2, this is 2, this is 1. Everywhere, huh? So V2 minus this V1, I'll bring this side. So if you see, U1 minus U2 equals to V2 minus V1. So basically what it is, change in the velocity before collision is equals to the change in the velocity after collision. So what you can write it as, therefore, or thus, for a perfectly elastic collision, perfectly means without any loss of energy. Okay, perfectly elastic collision, the relative velocity. What is relative velocity means? Relative velocity means difference in the velocities. relative velocity of approach before collision is equal to velocity recession, you can use the word. See, this statement they will anyways give you to prove. Okay, this statement will be already there in the question. So you can just have to write it. Therefore, this perfectly elastic. You just have to repeat a question over here. You will be asked to prove. Okay, prove that for a perfectly elastic collision, the relative velocity of approach before collision is equals to the velocity recession after collision. So whatever comes in the question, you just have to copy paste here. Worst case, if you forget it, at least remember that velocity before collision is equals to the change. Okay, the word you can write change in velocity before collision is equals to change in velocity after collision. Next part is velocities after collision, means to calculate what is v1 and v2 after the collision. Just now what we had got, the answer, we know that u1 minus u2 equals to v2 minus v1. So mark that as equation 5. This is a continuation of that, or if this is a separate, no, then at least this equation you should remember, then it, okay, but you will have to substitute in main equation also. It's a full thing. So u1 minus u2 will be this, so mark it as equation 5. So as per that, our aim is to find what is the velocity v2. So what will happen, I'll bring this v1 this side. So this is the value of v2. I want to know what is basically v2. So what I did, v1 I brought this side, so it became plus. Now what I'll do, put the value of v2 in equation 1. So what was the equation 1? m1 u1 plus m2 u2 was equals to m1 v1 plus m2 v2. This was the equation 1. So wherever there is v2, put this value. So v2 is only here. So this whole value will come here. u1 minus u2 plus v1. Open up the bracket now. This is m2, no? Now multiply inside. m1 u1 plus m2 u2 equals to m1 v1 plus m2 u1. I'm just multiplying m2 to all the terms. Minus m2 u2 okay. Now what I'll do is M1 U1, all the V terms I'll bring together, V1 terms, and all the U terms I will take on the other side. So what I'll basically do is U terms I'll bring on one side, whichever is having U1. So which all terms are having U1? Here, this one, or U, all the U terms basically, initial velocity terms. So all the initial velocity terms I'll keep on the left hand side. So as per that, these two are already on the left hand side. So which other U terms are on the other side? Bring them this side. So this will be minus M2 U1. This will be plus M2 U2. These two terms I brought it on the other side, so their signs will change. And V terms I'm keeping on one side. So M1 V1 plus M2 V1. All the initial velocities on one side, all the final velocities V on the other side. Whichever were there already on the left hand side, I have not changed their sign. I kept them here only. The only ones which I transferred them on the opposite side of the equal to sign, only those signs I have changed. These two terms I have transferred this side because they were U terms. So basically on my left hand side I have everything in terms of U, and right hand side I have everything in terms of V. Now over here what is common? V1 is common, so you can take V1 common there. Before that, what I can do is, if this and this term is same, I will notice these two terms are same. So it's like x plus x will give me 2x. If I add this, this will give me 2 times m1 u1. This term I will write minus m2 u2, and this plus this will give me 2 times m1 u1 on u2. This I'm keeping like this only. These two terms are same term, so that's why I added. This is u1. Now what is common between them? u1 is common. Between these two terms, u1 is common. Now between these two terms, v1 is common. So what I'll do is, I want to find basically what is the value of v1. We are finding velocities after the collision. So if I want to find what is the value of v1, this is like multiplication. So this term I'll bring this side, so where it will go to the denominator. So I want to find the value of v1. So this one I'll bring here. So what entire thing will get divided by this one. m1 minus m2 u1 plus 2 times m1 upon this whole thing will come here. That's the value of v1. You can distribute if you want. So this will be m1. This will get divided on both the terms. M2 this is a, make sure. You all are not correcting also, no? At least you all should be attentive here. See, this is M2, 2 times. You are just copying from the board as it is. This is M2. See, should have been M2. Okay, so that is your V1. But also from equation number 5, okay, what was equation number 5? From equation 5, equation 5 was U1 minus U2 equals to V2 minus V1. So as per that logic, what is V1? V1 will be nothing but take everything on the other side, U1 minus U2 minus V2. But I don't want this negative. So everyone's sign will change. So this is minus U1 plus U2 plus V2. Okay, so this is the value of V1. So put again value of V1 in equation 1. Earlier what we had done, we had put the value of V2 in equation 1. Now we have to put the value of V1 in equation 1. So what is the equation 1? M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. This was the equation 1. So put wherever there is V1, put this value over here. M1 instead of V1, I'll put this. You can change the order also, no problem. You can start with V2 also, it doesn't matter because all are additions and subtractions. M1 plus M2 V2. Now open up the bracket. Plus M1 U2 plus M1 V2 now like previous case, bring all the U terms on one side and one with the V terms upon the other side. So basically U, these are all the U terms. So they should be on one side, whichever side you want, whether it's left hand side, right hand side, doesn't matter. This you can bring on one side, rest. So this will be, if I'm bringing this side, this one will become plus. This one will become minus. These I'm keeping on the right hand side only, so their signs will not change. Now, see this and this term is same. So this I'll write together. This I'll write next. These I'll add up, so they'll become 2 times M1 U1. Now, whatever is common, we'll take out common. Here U2 is common. Here U2 is common. So take out U2 common. In here V2 is common. So basically now we have to find a value of V2. So this is again multiplication. So V2 we keep here only. This whole thing will go to the denominator. So M2 minus M1, 2 times M1 is 1 upon M1 plus M2. So I found a value of V2. What is the value of V2? Distribute this M2 minus M1 upon M1 plus M2. So this is the value of V2. So we got the velocities, okay, after collision. If you want to calculate what is the velocity of V1 and body 1 and body 2 after the collision. So this is the formula. First we derive for V1 and the second one is for V2. Now there are two cases for this. So first I'll just write the formula again and keep. So write them together and keep. You have to remember it to solve the problem. So V1 is basically M1 minus M2 upon M1 plus M2 times U1. You put the bracket for the whole thing, okay? Plus 2M2 like this you can remember. So this is the formula for V1 and for V2 it is this is the formula for V2. You have to remember this in case if you have to calculate the velocities after collision. If you know the initial velocities of this of the objects and the mass, now you can always calculate the final velocity. So there are different cases. Accordingly, this formula can change. So case one is when the two bodies suppose have equal mass. If M1 is equals to M2. We'll take it as a common M then. So calculate in both the cases what will be of V1 and V2. So case 1 V1 is what? So in both cases it will be M only. Everything will be M now. Okay, if considering like M1 is also 10, M2 is also 10, so this will be 10 minus 10, 10 plus 10 is it. So this will become 0, M minus M. And this will be 2M upon again 2M. So answer is so velocity of the second body will come to the first one. So V1 will be equals to U2. Same way calculate V2. Put everywhere M. This was for V1. So for V2 what will happen? V2 will be again M minus M So this will again become 0. M plus M is to M. So they will become ulta. So basically what they are trying to say is, suppose if this one was 10 kg and this one was also 10 kg and they suppose collide each other. Okay, and this one was moving with suppose 5. This one was moving with 10. Okay, it's always this one's velocity after collision, no? This one's velocity will go to this one will go here. They will get exchanged. So whatever was initial of this one will become final of the other one. Your U2 will become get as V1. So this one's initial will become this one's final. This one's final will become this one's initial. This is case 1. Another case is that it is case 2. When the target body is at rest, means one body is at rest and the other one is moving and coming hitting this one. So basically this one is moving but M2 is at rest. So obviously U2 will be 0 if it is at rest. So use the formula and calculate. What is the formula for V1? M1 minus M2 upon M1 plus M2 times U1 plus 2 times M2 upon M1 plus M2 times U2, and we will calculate what is V1. U1. Okay, now mass is not same, huh? Now it is different. M1 minus M2 upon M1 plus M2. Now this will be 0. So substitute this as 0. So this whole term will go. So basically V1 will be only this part, M1 minus M2 upon M1 plus M2 times. Same way calculate V2. This was for V1. We'll calculate for V2. The formula is M2 minus M1 upon M1 plus M2 times U2. U2 is 0. This we have to keep as it is. So your V2 value is 2 M1 plus M2 times. So this is your answer for V2. Okay, I will stop here. Only one more, that energy this for inelastic is left, one derivation. Okay, and some few problems. So next class I will finish with this chapter. and then I will start with gravitation. Don't leave, huh? Wait, I'm taking attendance.